Welcome to The Explainer. Today, we're diving deep into one of the biggest, most frustrating problems in AI, hallucination. Why do these incredibly smart models sometimes just make stuff up? Well, a recent academic paper offers a pretty startling answer, and we're going to break it all down.
Okay, so check this out. Researchers asked 3 of the top AI models a simple question about one of their own authors. And, well, they all gave different, very plausible sounding and completely wrong answers. This isn't just some random glitch. It's a perfect window into a really fundamental problem. So what's actually going on here? Now, you might think it's just a bug, right? Something to be patched. But what if I told you it's something much, much deeper? A groundbreaking new paper argues that hallucination isn't an accident at all. It's actually a direct, almost logical consequence of the very system was used to train and test these AIs. All right, so let's really dig into this puzzle of AI-generated falsehoods, because we're not just talking about one kind of error here. We're talking about a whole spectrum of confident mistakes. I mean, look at these examples. The errors range from the factual, like getting a birthday wrong 3 different times, to the, logical, like failing to count the letters in a simple word. The thing is, these aren't just stumbles. They are confident, plausible-sounding lies. And to really get it, we have to look at the AI's entire life story. The paper breaks the whole problem down into 2 key parts. Think of it like a mystery novel. First, you've got the origin story. How are these hallucinations even born? And second, you've got the survival story. Once they're out there, why do they stick around and even get stronger?
Okay, Act 1. Where do hallucinations come from? It all starts way back in the pre-training phase, where the model is just reading a gigantic chunk of the internet trying to learn how language works. Now, here's the part that really blew my mind. The paper shows that even if you trained a model on perfectly clean, error-free data, it would still hallucinate. They're not just a result of the model learning bad information, they are a natural, statistical byproduct of the learning process itself.
So to prove this, the researchers did something really clever. They took the super complex task of generating text and boiled it down to a much simpler question, a yes or no question. They call it the is it valid problem, or IIV. So instead of asking the model to write a correct sentence, you just ask it to judge if a sentence is correct or not. Simple. And this formula is the key. The research found a direct mathematical link here. What this says is that a model's error rate for actually generating text will always be at least twice as high as its error rate for just making that simple yes-no judgment call. So here's the crucial point. If that simple yes-no task is hard for any reason, then generating correct text is going to be even harder. And that classification task can be hard for lots of reasons. Maybe the facts are just random, like a birthday that only shows up once. Maybe the model's design just isn't right for the job. Or maybe the problem is just fundamentally complex. In any of those cases, errors are basically statistically inevitable. Okay, so hallucinations are born from statistics during pre-training. But why don't we just get rid of them later on, during post-training? Well, this brings us to Act 2 of our story. And honestly, this part might be even more troubling. Here's the core of the argument. The paper uses this fantastic analogy. We evaluate our AIs like they're students taking a multiple-choice test, where there's no penalty for wrong answers. Now, if you're in that situation, what's the best strategy to get the highest score? You guess, you always provide an answer. And this just lays out the central conflict perfectly. On the one hand, what we want is a model that's humble enough to say, you know what, I don't know. But on the other hand, what our tests actually reward is a model that makes its best, most plausible-sounding guess, because that's the only way to get any points. And if you need proof, here it is. This table shows some of the most influential AI benchmarks out there, the ones that drive the industry leaderboards. Just look at that last column. None, none, none. Over and over, these tests give 0 credit for admitting you don't know. The entire system is built to reward confident guessing. And the result of this is just wow. On the left, you see a pre-trained model. The bars are pretty close to that diagonal line, which basically means its confidence matches its accuracy. It knows what it knows. But look at the chart on the right. After post-training, the phase that's supposed to make it a better test taker, it becomes systematically overconfident. It's way more confident than it has any right to be. In short, we're teaching it how to bluff. So, if our own tests are actually rewarding the very behavior we're trying to stop, how in the world do we fix this?
how do we build an AI that we can actually trust?
The paper argues for what it calls a socio-technical solution. And that's really just a way of saying it's not enough to build another little test for hallucinations on the side. To really fix this, we have to fundamentally change the main evaluations that the entire AI community uses to decide what's good.
And they propose a really clear 3-step path to get there. First, as a community, we just have to admit that the current system is broken. Second, we need to go in and change the scoring rules for those big, influential benchmarks. And third, we have to start giving the AI explicit instructions on how to deal with being unsure. And here's a perfect example of what that kind of instruction could look like. A prompt like this completely changes the game. By adding a huge penalty for being wrong, guessing is no longer the smart play. All of a sudden, saying, "I don't know," becomes a rational, score-saving choice, just like it is for us when we're taking a high-stakes exam.
Which brings us to the core kind of paradigm-shifting takeaway from all this research. Hallucination isn't a malfunction. It's the model doing exactly what we've trained it to do. It's a feature, not a bug, of the evaluation systems we've built around it.
And that leaves us with a final, really provocative question. For years, the big race in AI has been to build bigger and better models. But maybe, just maybe, to build truly trustworthy AI, the most important work isn't about improving the models themselves, but about fundamentally changing the tests we give them.